Hi class, today we're going to be giving some notes on chapter 3. I know we're not using the book a whole lot, but that's where you can find some of this information if you need it. So we're going to go through some things that are important for living things. Let's review just a tad. In the last few days, we've talked about characteristics of life. And so we gave 7 characteristics of life that we know of here on Earth that we would say, in order for something to be considered living, it needs to meet those 7 characteristics of life. So now we're going to move into some topics that relate to what living things need in order to survive. So the first one we're going to talk about is water. And water is very important for living things. We'll go through some reasons here in just a few minutes. If you're looking in your book or you need to look at a book, it'll be chapter 2, section 3 for our class. All right, so first, if you're using the notes packet, you'll see the first page of your notes packet has definitions or just terms. And that's really what we're going to cover today in this video. So structure of water, it's held together by covalent bonds. If you've had physical science already, or chemistry possibly, you would have talked about covalent bonds. And they share electrons. So oxygen and hydrogen share electrons. And we have 2 hydrogens for every 1 oxygen. So you can see a picture there. It kind of looks like a Mickey Mouse head or a V. And if you look at this next picture, it kind of looks a little bit more like a Mickey Mouse head. So if you're using the notes packet, you can draw in the O and the 2 H's. So you can identify the parts of the water molecule, and you can put the positives and negatives as well. You can see down here in the picture, we have our positive ends and our negative ends. And this positive and negative piece is important when we talk about polarity. So if something is a polar molecule, it has an uneven charge. And if you look at this molecule here, and we have the positives and negatives drawn in, what we see is that this oxygen side, it's a bigger atom, and it actually tries to hoard all of the electrons, and so it gets a little more negative on that end. And then the hydrogen, it's such a tiny little molecule, and it only had 1 electron to start with, and so it becomes a little bit more positive. And that's really all polarity means. It has this uneven distribution of charge, and it also often will bond at an angle because of that. So that becomes important when we look at what water can dissolve. Water can actually dissolve many things. It's actually considered the universal solvent when we talk about, maybe in physical science, you might have done some things in what water dissolves. But there are some things that water cannot dissolve, and often you'll see these, like if oil and water, if they're put together, you'll see that they separate from each other. So the kind of rule that goes with it is like dissolves like. And what that means is polar substances will dissolve other polar substances, and nonpolar substances will dissolve other nonpolar substances. So if we think about oil and water and we understand that they don't mix, what actually is happening is we know water is polar. And so since it won't mix or won't dissolve oil, we can take this little rule here and then understand or give an assumption that oil is nonpolar. But while it can't dissolve oil, it can dissolve many, many other things. And so that process of dissolving is that the positive end of water will attract to the negative ion of a substance. I should say substance on there. So that negative ion of a substance could be like the chlorine in sodium and chlorine, which would be salt. So that ionic compound that's created between sodium and chlorine, the chlorine has a negative end. The negative end of water will attract to the positive ion of a substance. So basically, when it does this, it breaks that ionic bond and it causes water to dissolve that substance. So when you think about things that water can dissolve, which is an awful lot of things, that is because those objects or those solutions were polar. So polar will dissolve other polar things. Now, water has a special bond between water molecules. And so you can see this one water molecule here. We have one here. An oxygen end will attract to, because it's negative, will attract to a hydrogen end of another water molecule. And that's called a hydrogen bond. So right here between 2 water molecules, we see a hydrogen bond. It is a weak chemical bond, but it actually does help it perform pretty cool things. So when we have hydrogen bonds between 2 water molecules and they're attracted to each other, it creates surface tension. And that surface tension is what allows maybe a water bug to run across the surface of water. or allows you to fill up a glass to the very top, but then still add drops of water and it won't spill over the edge, even though it is kind of looking like it should spill or it's making this rounded top to it, it doesn't spill over. And that's actually going to lead to another term. We have another term called cohesion. And cohesion is when these water molecules are attracted to each other and it creates surface tension. So a lot of times what you'll see is a water droplet next to another water droplet, and it will actually just like attract to it and make this water droplet bigger. Another thing that you can see is that surface tension, where it bubbles up on top of a leaf or a surface, and it creates a bubble look to it. And that is just surface tension, which is actually related to the term cohesion. So a lot of times we're going to learn another term here, adhesion. A lot of times you need some little thing to help you remember which is which. So I don't know, you can try this. Cohesion, that beginning co, you might think of it in like cooperate is a place where you might see that, or co-captain. And that is a co-captain, two individuals that are working together for that same goal or coming together. And then cooperate, people coming together to work towards something. So you can think cohesion, two water molecules coming together, if that helps you. Adhesion is when water, because of its properties, are able to attract to another surface or another object that's not like it. So here we see adhesion along the insides of a straw, where the water almost seems to like climb up the straw on its own. This is really important for plants. So plants have water that needs to get all the way to the top of the leaves on top of the tree, and the water molecules actually are kind of attracted to the sides of the inside of that plant through its, like what a plant would have as blood vessels, basically. And that water will travel up the stem of a plant against the force of gravity. So it's attracted to something that's not like it. You would probably see this on maybe a gutter where you see water droplets that seem to just hang or defy gravity like a magic trick. And they just kind of hang there on the side of a gutter but don't actually fall off. Another example we brought up today in class was on the sides of a shower. So when you take a shower and you see water droplets along the sides of the shower or walls of the shower, that is adhesion. Okay, and then cohesion and adhesion working together is called capillarity. And capillarity is when these molecules, water molecules, can go up a narrow tube against the force of gravity. And most importantly, this happens in plants so that you can have water traveling up to the top part of that plant. Okay, so the last thing here with water and kind of its importance for living things deals with homeostasis. So it takes a really large amount of energy to break water molecules apart. So the reason this is really important is when we look at our bodies, we're made up of lots and lots of water, but we have to live in environments that aren't always suitable to the temperature of our body. So we might live in really cold conditions, or we might live in really hot conditions, or we might spend some time in one of those environments. And water takes a really long time to get to the next temperature. If you've ever tried to freeze water, you'll notice that the top layer of your ice cube tray will turn to ice way before the middle of that ice cube tray. So you might think, oh, I've had that in there a long time. You pull the ice cube tray out and you see a layer of ice, but then underneath that, you see that it's still liquid. Or maybe if you like to ice skate and you have a pond, you might think, oh, it's all frozen over, but actually you would need it to freeze even lower down into the pond before you would want to step on it so you don't fall through. So water takes a long time to change temperature from 1 degree to the next. And it happens when heating things. I always bring up the example of macaroni and cheese. You put a pot of water on the stove, you want to make some mac and cheese because everyone loves mac and cheese, right? And so you put it on the stove and it takes a really long time for it to heat up. And so that's why they made microwave mac and cheese, right? So it takes a long time for it to change temperature. And what will happen is when you go outside on a really cold day or a really hot day, you'll find that your body does not change temperature. It stays at a constant temperature for a lot longer than maybe you would expect because we are made of water.